So now we will study one more data structure, that is stack. Stack it is part of linear data structure. Okay. In the previous class we have studied under linear data structures arrays and linked lists. Okay. Now we will study stack. A little bit of, if we have a theoretical idea, then we will do the practicals. And as I told you, that data structure, it is not a programming language, but it is a data structure means it is a way to store the data in computers memory locations. So we can store the data in different languages in different ways. Okay, C has data structures in different, C++ has storing of data in memory locations different. Okay, Java, Python, everybody have syntax is somewhat different. So now one more, that is linear data structure stack. Stack, it follows the LIFO. LIFO means last in first out. Okay, this is the stack of books. See, this is the stack of books. So initially the books stored from this is the starting point, then after one by one. So this stack follows, this is a data structure, how to store the data elements. Okay, so when if it follows the LIFO means last in, the element which is entered last, that will be out first. Last in, that's why it's called LIFO means last in first out. Suppose this book is entered, kept at last, and it will be taken out first. Okay, so it follows, the stack follows this principle. So it allows the operations like insertion and deletion from one end of the stack. So stack has two ends. This is the one end, this is the one end. So this is the top end, this is the bottom end. This is the bottom end, this is the top end. So the insertion and the deletion, you can insert at the top end and you can delete the elements from the top end also. So insertion and deletion from one end of the stack, that is top. We can't delete, otherwise insert elements, mean data elements at the bottom end. Always elements will be removed, deleted means removed or inserted at the top end. So stacks can be implemented with the help of contiguous memory location. That is what contiguous memory location will be followed by array. Okay, contiguous memory. So stacks will be implemented with the arrays, and non-contiguous memory locations, a linked list. Okay, linked list follow the non-contiguous memory location. Why? Because linked list follows why non-contiguous. We can say that because every node will be connected to another node with the pointer, with a address. So that's why any memory location can be pointed to any memory location. So no need to be contiguous. Contiguous means consecutive memory locations, because in linked list there is a pointer. That pointer will hold the address. So one memory location can be pointed to any memory location. No need of contiguous method. That's why a linked list. So stack can be implemented with the help of both the contiguous memory location data structure, that is array, and non-contiguous memory location data structure, that is linked list. Okay, so if we want to know the real life examples of stacks, this is what some books kept as a stack. Okay, some cards, a deck of cards, piles of money. Okay, somewhat. So next let us try to understand somewhat so the main operations in the stack are what? Insertion of data, deletion of data, deletion of element, insertion of data. So insertion of element is called push operation. Push operation means, suppose if I am inserting a new element into the stack, that is called push. So push is an operation to insert new element in the stack, that is called push operation. If I want to remove any data element from the stack, that is called deletion, or removing, it is called pop. Pop operation. Pop operation means removing and deleting operation elements from the stack. That is called pop operation. See. So in the diagram, one data element, then one more data element, next data. So this is the last data entered. This is the top end. Now element pushed. Okay. So now this is the last element pushed. So as I do, it follows the LIFO, last in first out. It is to be taken out first out by the pop operation. Element pushed means inserted in the stack. That is, whatever pushed means last in first out. It is kept at last and it will be taken out first by pop operation. Okay, pop means removing of, deleting of element from the stack. This is the diagram. Okay, now one more. If anything, stack operation. So always the operations are performed at one end only. Means what do you mean of this? Operations means insertion, keeping of data, and deletion or removing of data. Any operation, they will be done at one end only, that is top end, not from the bottom. Okay. So that elements will be taken out from the top of the stack. So now this is enough. Whenever we do the practicals, we will try to understand some application of the stacks. We will try to understand that what are the basic applications where the stack will be used. So many applications they have given here. So we will try to understand somewhat, because until unless we will not do the practical, you will get difficulty. So many can match parentheses using stacks. We can match parentheses using stacks. Stacks allows us to check the expression syntax in the programming environment. So we need to, whenever we will do practically anything, so operating system functions, stacks are also used in operating system functions. So whenever operating system is like Windows, Unix, Linux, both are same, but Linux is the graphical user operating graphic GUI based operating system, and Unix is the CUI, character user interface operating system, and Macintosh, Mac OS. So in any operating system, stacks are being used. Okay, this as per the statement. So stacks are also used in undo and redo functions in an edit. So this is normally we know undo function and redo functions at the time of edit. Suppose if you are editing anything, that moment you can normally we do this function. So one is this, you understand, and it is being used in operating system functions. Two, we can manage function calls using stacks. Function calls we can manage using stacks. Some evaluation of arithmetic expression in different programming languages. Suppose so many programming languages already we have studied, Java, Python, C, C++. Now in this programming language, if I want to evaluate of arithmetic expressions, stacks will be used. So whenever we will do all them in where in, that is what in practically, that moment you will get all the idea. And one more, that is Q. It is also linear data structure. It is similar to stack, but it has some limitations on the insertion and deletion of the elements. See, insertion of an element in a queue is done at one end. Okay. And that is what removal is done at another end, opposite end. Suppose element is inserting at this end, so element will be removed from another end, opposite end. Suppose this is the first end, so element is being entered at this end, first end, this is the starting end, and element will be taken out from the opposite end. Okay, that is the difference. But in stack, only insertion and deletion can be done in only one end, that is top. Okay, we can't do any operation at the bottom end. But here in queue, we can enter the element at one end and we can